In this first video, we're going to talk about the natural log function, or natural log is log base of e. Hopefully you've taken time and looked over this bit of information from the course notes. But I just want to kind of summarize some of the points and facts about the natural logarithm. So first and foremost, because of its definition, the derivative of the natural log is just 1 over x. The derivative of the natural log is just 1 over x. And of course, then by the chain rule, the derivative of ln of u would be 1 over u, the outer function, times the derivative of u prime, the inner function, or as we often abbreviate it, the derivative of the inside, u prime over the inside. That's how we do derivative of natural log. We can usually do it using that idea, do it pretty quickly with the chain rule, without having to maybe write out as much detail as we do for some other functions. Okay. Another thing about logarithms you need to be aware of, not just natural log, but any log, is that we can break them up using logs. Log of a product is the sum of the two logs. Log of a difference is the difference of two logs. And log of something to a power is that power times log of a. So log of an, or ln of a to the end, this case is here, equals n times ln of a. And we'll often use those properties to make the derivative process with the natural log a little bit quicker. So some specific properties of the natural logarithm. First of all, because of its definition in terms of that definite integral, its domain is from 0 to infinity. Natural log takes on all real numbers. The derivative of the natural log is 1 over x, which if you're looking at 1 over x just for positive numbers, 1 over x is always positive. So since the first derivative is positive, it's always increasing. The derivative of 1 over x would be negative 1 over x squared, which would always be negative, which means that the graph of the natural log function is not concave up. That is a mistake. It is concave down. Right? It is always concave down because its derivative is always negative. It's concave down. So putting that information together, we have this basic graph of the natural log. It's only defined for real numbers. It actually has an asymptote there at 0. A vertical asymptote. It crosses the x-axis at 1, 0, and then it continues to increase, but it actually keeps increasing at a slower and slower rate because, again, the derivative is 1 over x. So it's still positive, but as x gets bigger, 1 over x gets smaller, and so it increases at a slower and slower rate. And you can see the shape here that is concave down. The graph is concave down from 0 to infinity. So those are some basic facts about the natural log function that we just want to be aware of as we kind of go forward here and start to look at some derivative problems with the natural log.